Good morning. Nice. Looks like everyone's rolling in. Okay. Dum-de-dum. How many viewers do I have? Good morning. I'm setting up my code for the lesson, so. How many viewers do we have? All right, we're at 20, so I'm going to go ahead and get started since we're already a few minutes late. Okay. I'm going to switch to my document camera to start out. So actually the lessons for SL and HL are kind of related today, so go ahead and pay attention no matter which class you're in. Autofocus this a bit. Okay. So today what I'm going to, hang on a second. Today what I'm going to be talking about are arrays, okay? So arrays. And arrays are, this focus? Can already tell things are just not going my way today. Arrays are a list of objects. Okay, a list of objects. If you want to declare an array, you would say whatever the object type is. So maybe you want to declare an array of characters, okay? So I would say char, and then I put square brackets after that. That's what indicates the array. And then I give it a name. So maybe char array. equals new char, and then important thing here is an array has a fixed size. Okay, so right here you have to put how many characters are in that array. So maybe I want to create an array with 3 characters in it. Okay, so that's going to create an array. All right, with 3 characters. Now the value of those 3 characters are not set yet. So what we then want to do is we want to initialize the array with values. Okay, so the best way to do that is with a for loop. Okay, so I could say for int I equals 0. Good morning. I less than character array dot length. So character array dot length is going to return 3 because that is the length of the character array. And then I plus plus. And then I say maybe, I don't know, character array I is equal to, I don't know, let's say A. So what this is going to do is it's going to set, so this is how what's going on right here is you're accessing the ith element of the array. Okay. So, and we're setting it equal to A. So this is going to set all 3 elements of the array equal to A. Now, one of the things that I want to point out is that the first element of the array is the 0th element of the array. So we have char array 0 is the first element. Char array 1 is the second element, and char array 2 is the last element. So notice how the last element of the array is at the position length minus 1. Okay? Because this is an array of length 3, so the last one is at 2 because we started at 0. So that's just a little computer science thing that they do. Okay? So this is one way to initialize an array. Okay? So arrays are kind of built for loops. All right? If you want to do something with an array where you go over the entire array and you do something with the data within that array, you're going to use a for loop. Okay? Another way to initialize an array to set its values is to use curly brackets. So let's say I wanted to create an array of strings. Okay? So I could say actually, let's create a Boolean array. All right. So maybe I say Boolean array, and I'm going to call it B equals, and I'm going to say true, false, true, true. Okay, so you just put the values in between curly brackets. You separate them by commas. So this is basically creating an array of length 4. So this is B0. This is B1, etc. Okay, so that's the second way that you can. That's the second way that you can initialize an array. So this method is really only useful if you have a short array. If you have a huge array that has many elements, then this is just not going to work, obviously, because you have to manually type out each element of the array. Okay, so let's go over to code board and sort of see this in action. So I've got some. So I have, if you look here, I've got a string array, and I called it S array. And for this one, I used the second method of initializing an array that I talked about. So this would be a string array of length 3. And we can see that it has the 0th element of the array is high. The first element is bug. The second element is hazel. Okay. And then I also defined an int array. So int in square brackets, int array. Oops, what did I do there? And I said it's a new integer array of length 5. Okay. So notice how this is not initialized. So if I want to use this array, I have to set the values. Okay. So let me do that. So I did that in a for loop. So this for loop right here initializes int array. And so you can see that I have for int I equals 0, I less than int array dot length. So that's how you, and then I plus plus, that is how you iterate over an array. And I said that the ith element of the array is equal to a random number between 0 and 100. Okay. If you haven't used the random number from the math class, let me just show you how that works. So let me find it. Okay, so there's a static method in the math class. It's called random. And it says it returns a double value with a positive sign between 0 and 1. Okay? So you can see what I did is math.random is going to give me a random double between 0 and 1. So if I multiply that by 100, it's going to give me a random double between 0 and 100. But I don't want a double, okay, because it's an integer array. So what I'm going to then do is cast that double as an integer. Okay, so turn it into an integer. So basically this line of code sets the ith element of the array equal to a random int from 0 to 100. Okay, so that's what that does. So now what I would like to do is I would like to print out the contents of the array. Okay, so I have system.out.println. The array class, or if you make an array, it actually has a built-in toString method. If you want to use the toString method, you have to import java.util.arrays. And it's a static method of the arrays class. So you can see arrays dot toString, and then I have parentheses S array, and then I do the same thing with int array. So let's compile it, and let's see how it prints the array. So you can see it puts the contents of the array in square brackets, and it just says, "Hi, Bug Hazel." And then it says, I guess my random array of integers had those values. If I compile this again, and I run it again, we can see that the random numbers have changed because each time the program is run, it's selecting new random numbers for me. Okay, so you can see the numbers are changing every single time. If I wanted to just print, let's say, the first element of the string array, then I would say S array. Let's say I wanted to print element 1, so I would just access the first element of the string array like that. And the first element of the string array is bug, right? Because hi is the 0th element, bug is the first element, etc. So it's going to print out bug, a third line that says bug. You can see right there it says bug. All right. If you want to define a method that outputs an array, let me show you the syntax for that. I would say public static, and let's say it's going to output an int array. So let's say the function outputs an int array. So I'd say int array, and then I have to name the method. So I'm going to call it +1, and it's going to take in an int array, which I will call, I don't know, my array. Okay, and so what this is going to do is it's going to output the same array as my array, but it's going to add 1 to each element of it. Okay, so how would we do that? Well, first, let's create the array that is going to hold the output. Okay, so I'm going to say int output equals new int array, and I have to decide the length. Well, the length of the output is going to be the same as the length of my array. So I'm creating a blank integer array called output that has the same length as the input. Maybe I should just call this input. That's a better name for it. Okay, so now what I want to do is I want to set the output equal to the values of the input, but I want to add 1 to each value. Okay, so I'm going to say, again, I'm going to do a for loop for int I equals 0, I less than output dot length, I plus plus. I'm going to set output, so set the ith element of output equal to the ith element of input, but then I'm going to add 1 to it. So that's why the function is called +1, because I'm just adding 1 to it. All right. So basically, output is a copy of input where each element has 1 added to it. Then I am going to return output, and that would return an int array, like I said I was going to do. Okay, so that should work. let's go ahead and go back to the main method, and I want to print my +1 method acting on int array. Okay. But notice how I have to convert this to a string. Okay, so I've got to use the arrays dot to string on my returned on my array. Okay, so let's compile that and run it. So we can see that I called my +1 method on int array, which is going to add 1 to each element of the array, and then I turned it into a string. So you can see that these two int arrays, each element has 1 added to it. So that's just a silly little method that I wrote for this int array. Okay. So that's how you do methods with arrays that output arrays. What would happen if I didn't use the toString method? What if I just said print sArray, and I said print int array, and I said print +1 int array, etc. So I have not used the toString method. Let's see what it does. Whoop. Okay. So you can see what it's done is it's just printed out the memory address of each of these variables. So whenever you use the print method, unless you've defined a toString, unless you call a toString method to print that, it's going to just print the value that is on the stack, which is just a memory address. Okay, so that's something to keep in mind. All right, so I'm going to talk a little bit more about theory here. Go into the, so this is going to be important for actually the HL students as well. Let me check and see if I have any questions. No questions. Cool. So when you create an array, all right, so we're going to talk a little bit about the implementation of arrays. Okay, so let's say you make a line of code that says, you know, let's say int array, and let's call it values equals a new int array that has, let's say, 4 elements. Okay, so what's going to happen on the stack is, remember, the stack is just all the instructions for the program, is you are going to get the memory address of vals 0. So what's stored on the stack is the memory address of the 0th element of values, okay? And then in the heap, so here's the heap is just the blob of, so remember the stack is the instruction list of the program, and the heap is where the actual data is stored, okay? So when you create an integer array that has length 4, what it's going to do is it's going to block out 4 consecutive spaces in the heap memory. So like this. It's blocking out 4 spaces in the heap. And then the stack is going to contain the memory address of the 0th element. Okay? So that's how the heap is stored, or I mean how the array is stored. One of the things about arrays that is a disadvantage, okay, is that you can't increase the size of an array. Okay, so we would say that it is a that the size of the array is static. You cannot increase the size of the array. Why is that? Well, because let's say that the memory address of the 0th value is memory address 149. Okay, so that means that the stack is storing 149, memory address 149. Then the first element of the array is going to be stored at 150, and then the second is going to be at 151, and then the third one is going to be at memory address 152. Okay? So if you wanted to increase the size, the next, if you wanted to make this an integer array of size 5, you would have to block out the next space in the heap. So the 5th one would be in space 153. But the thing is that the heap has already used that next space. Okay? That space is not guaranteed to be open. So when you made this declaration, the computer is going to devote a single block of memory for this array. Okay? And so any additional spaces are not guaranteed to be open. It's a single consecutive block of memory. So that's a disadvantage. You can't increase the size because you don't know that the next space is available. It could be used already by something else. So maybe this next space is holding a string and it has nothing to do. So you can't go to the next memory address. Okay? What is the advantage of an array? The location of each element of the array is known. Okay? So, for example, if I want the second element of the array, then I just go to the memory address that is the memory address of the 0th element plus 2. So it's really easy to determine where the element 2 of the array is stored, because you just go 2 memory addresses down. Okay? So that means that it takes the same amount of time to access every element of the array. So we call that, if it takes the same amount of time to access every piece, every part of the array, we call that random access. You can access a random element of the array in the same amount of time as it takes to access any other element. It takes the same amount of time to get to each spot, because it's just a simple calculation. If you want to know the 3rd element of the array, then you take the 0th element and you go 3 memory addresses down. Okay? So that's cool. So that's my lesson for the SL kids. But I'm going to go into the HL lesson, And actually, I want the SL to listen to this first part, okay? Because this is important. So for my HL students, we're going to talk about something called a linked list, okay? Now, a linked list has the advantage, okay? So what is the advantage of a linked list? A linked list is just like an array. You can have a linked list of integers, for example. The advantage is the size is not fixed. Okay? So because the size of a linked list is not fixed, you could add additional elements. So you could basically make the array longer if you wanted to. So we call that dynamic. Linked lists are dynamic, and that's an advantage. What are the disadvantages? The disadvantages are that there is no random access. It takes different amounts of time to access different elements of a linked list, and I'll explain why in a moment. And the second disadvantage is it takes up more space, and that will become obvious, more memory, okay? And that will become obvious when I explain how the linked list works, okay? So let's explain, how does a linked list work? So you have your stack, and you have your heap, okay? And so when you declare a new linked list, okay, all you're going to store is the memory address of that first element, the 0th element of the linked list, okay? So, all right. So that might be element, let's say that the 0th element of the linked list is stored in memory spot 300. Okay? So what it's going to do in the heap is it's going to create a slot in space 300. Okay? And that slot is going to contain 2 pieces of information. Okay? It's going to contain 2 pieces of information. It's going to contain the data. So maybe it's a linked list of integers. Okay? So it's going to contain an integer. But then it's going to contain the memory address of the next location, the next element. Okay? So maybe the next, and unlike an array where it's a continuous block of memory, there's no reason that they should be a continuous block. So maybe the next element of the linked list is at space 460. Okay? So now over at space 460, you have the next value of the integer. Okay? The next integer value. And then it contains the memory address of the following element, which might be at space 10. So over here at space 10, you have a different integer. Okay, and then if that was the last element, then this would store null. Null meaning it's just an empty memory value. Okay, so what we can see is that a linked list has its elements stored everywhere, just at random spaces throughout the heap. So why does it take more time to access certain elements of the array. It's because you don't know. Let's say I want to access the fifth element, or sorry, the second element of this linked list. Okay, I don't have any information about where that's stored unless I follow the entire chain. You see? So if I want to know where is the second element 2 of this linked list, I have to go to the 0th element, and then that says that the first element is stored at 460. So then I have to go to space 460, and then I see that the next element is stored at space 10, so then I have to go to space 10. So do you see how in order to get to element 2, I had to go through all of the previous elements, okay? And so this makes it slower to access elements that are towards the end of the linked list. So that if you want to look at elements toward the end of the linked list, it can take a long time because you have to go through the entire list in order to get to the end. You don't have to do that for arrays. Why does a linked list take up more space? Because you're not just storing the value, you're also storing the memory address of where the next value is. Okay, so it takes up more memory, and it takes more time to go through it. So let me talk about how you could implement a linked list. So there are a couple of types of linked lists. You have what's called a singly linked list. Okay. And in your linked list class, you would basically, what you store is, you store the head of the linked list, which is basically the 0th element. Okay. All right. And then you have you oftentimes also will store the tail, which is the last element. Oh, this is dying. Okay, so the tail is the last element. So here's the head. Okay, and in a singly linked list, you have the location of the next element, like this. So this is a singly linked list. And then you're also storing the location of the last element, so you have the tail is right here. Okay. If you have a doubly linked list, then you still are storing the head and the tail, but you have okay, it's just like a singly linked list, but the difference is that the nth element of the linked list also has the location of the previous element, like so. So what that means, for a singly linked list, you can only traverse the list in the forward direction because, for example, if you went to the tail isn't storing the memory address of the previous element. It only stores the memory address of the next element. So you can only go forward. But for the doubly linked list, you're storing the next element and the previous element. Okay, so what is the advantage of a doubly linked list is that you are able to traverse it forward and backward. The disadvantage is that it takes up even more memory than a singly linked list because in the heap you have to store the location of the of the next element, but then also the previous element. So each spot in the heap is going to have more memory used. Okay? So you are going to implement a linked list, I think a doubly linked list for your assignment. All right, I'll meet everyone in the Zoom room, okay?